Hello, this is geometry lesson 9.2. In this I will discuss circles. I will continue where I left. Few more concepts in this lesson. First concept is equal chords. The chords length are equal. They are equidistant from the center. Let's say I am taking chord AB and CD. They are of equal length. AB is equals to CD is equals to, let's say, x centimeter. They are of equal length. This is x centimeter. This is also x centimeter. But I want to say that if the chords length are equal, they are equidistant from the center. How we can prove this? Let me draw this. This is R, radius of the circle. This is also the radius of the circle. This is also the radius of the circle R. This is also the radius of the circle R. This point is, let's say, O. So can I say that triangle OCD is congruent to triangle OAB by SSS. Now we know that whenever the triangles are congruent, the corresponding parts are equal. So the distance from the center to the chords will also be equal. If this distance is h centimeter, this will also be h centimeter. Distance means perpendicular distance. Both distances will be same because the triangles are congruent. Or you can understand that whenever the triangles are congruent, their height will also be same, because congruency itself suggests that the triangles will exactly overlap each other, so their height will also be same. What is height? Height is the distance from center to the chord. Reverse is also true. Converse is also true. Converse, it means that if the two chords are at the same distance from the center, here I have taken the center O, the two chords A, B and C, D, they are at the same distance from the center. You can see that height is H and H. Now I can say that if this is taken E and F, if OE is equals to OF is equals to H, it means that if two chords are at the same distance of H centimeter from the center, then I can say that AB will be equals to CD. The chord length will also be equal. How so? You can easily prove that this is the radius of the circle, this is the radius of the circle R, this is the radius of the circle, this is the radius of the circle. Now can I say that triangle OAE is congruent to triangle OCF by RHS? Right angle is there in both the triangle. You can see that 90-degree angle is there, OAE as well as OCF. This is triangle 1. I am assuming triangle 1. This is triangle 2. Triangle 1 and triangle 2, they are congruent. Right angle is there, 90-degree. Hypotenuse are equal, R centimeter. One of the side is equal, that is H. Height is same. So these two triangles are congruent. Now these two triangles are congruent. Can I say that AE, if A is equals to X, the corresponding parts will be equal. This is X centimeter, so this will also be X centimeter. Now I know that the perpendicular from center to chord bisect the chord. If this is X, this will also be X. Perpendicular from center to chord bisect the chord. Same way this will also be X centimeter. So can I say that I have proved that AB as well as CD is equals to 2x 2x. You can see that here AB is equals to CD is equals to 2x. So it's an important property I am again summarizing is that if the chords are of equal length, they will be equidistant from the center. Vice versa is also true. If the chords are equidistant from the center, they will be of equal length. Next concept is very important. The angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the remaining part of the circle. So if I want to say that this is angle subtended by arc is PQ. This is the arc. This PQ is the arc. The angle subtended by this arc at the center is double the angle subtended by it at any point on the remaining part of the circle. I want to prove that this is, if this angle is, this will be at the angle at the center will be double of the angle at the any part of the circle. How we can prove that? Simply you have to just join these 2 points. Can I say that if this, all the 3 are radius, let's say this is point number R, this is radius of the circle, this is also the radius of the circle, this is also the radius of the circle. Now can I say that this triangle is isosceles triangle because the 2 sides are equal, the angles will be also equal. This is alpha and this will be alpha. Because isosceles triangle ROP is isosceles triangle, so these 2 angles will be alpha and alpha. If this angle is beta, this angle will also be beta. Again isosceles triangle. Now this angle, this angle is exterior angle of the triangle. Exterior angle of the triangle ROQ. We know that exterior angle is always equals to sum of 2 opposite interior angle. So this angle will be 2 beta. And same way, this is also the exterior angle of triangle ROP. So this will also be 2 alpha. So can I say that? You can see that now angle at the center is double the angle at any point on the circle. You know that angle PRQ. We know that angle PRQ, that angle at any point of the circle is equals to alpha plus beta. And our angle at the center POQ is double of that angle, that is twice of alpha plus beta. 2 alpha plus 2 beta means twice of alpha plus beta. So very important property, because most of the questions in triangles and most of the question on circles in aptitude exams are based on this property, that angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Now this arc, this second circle, the arc PQ is a, you can say that this is semicircle arc, because this is semicircle arc, because this passes through the center. PQ is a diameter. Now we know that this angle is 180 degree. Again this property will be applied. The angle at the center is 180. So angle subtended by the arc PQ at any point on the circle, this will be half. So can I say this angle will be 90 degree. Same way you can do like this. This angle you can take as many points as you want to take. This angle will also be 90 degree. So very important, the angle made by an arc, subtended by an arc at the center is double the angle subtended by it at any point of the remaining part of the circle. Same way I can prove that this is the PQ arc. Now the angle subtended by arc PQ is this one. This angle will be double the angle subtended by this arc. If this angle is x, this angle will be 2x. Angle subtended by arc at the center is double the angle subtended by it on the remaining part of circle. Next concept is the application of the concept I just discussed. Concept says that the angle subtended by an arc in the same segment of a circle are equal. This is the same segment. This arc is ABC. This is the arc ABC. Now angle subtended by that arc in the same segment, all the angles will be equal. I have just made 2 angles. It can be more than 2. They all will be of equal measures. If this angle is x, this angle will also be x. Why so? Because same property. This center, let's say take O. Now angle subtended by arc at the center is double the angle subtended by the same arc at any point of the circle. So this angle will be 2x. Arc is ABC. This angle is making, this arc is making angle 2x at the center. So by this property, the same arc is making angle x, and same arc is also making the angle x. So angle ADC will be equals to angle AEC, that is equals to x degree. Here I am discussing example that will make the concept that I just discussed very clear to you. Now the question says that AB is the diameter of the circle as the chord passes through the center. AB is parallel to CD, which is another chord. We need to find the value of angle X. One of the angle is given to us as 65 degree. So can we find the value of angle x? Just pause the video, try to solve yourself this question, then look at the way I have solved. Now I'm solving this question. Now how can you solve this question? Can I say that first can I join this O and C? Now if I join the O and C, you can see that the arc BC, look at the arc BC, angle subtended by the arc BC at the center, this angle will be double of the angle subtended by the same arc at any point of the circle. So any point of the circle, the angle is 65. So angle subtended by the same arc BC will be 130 degree. This angle is 130 degree. Now you know that OC is the radius of a circle. Same way this OB is also the radius of a circle. This will make OCB an isosceles triangle, and we know that in isosceles triangle angle opposite to equal sides are equal, and also we know that sum of all the angles in a triangle is 180 degree. So one of the angle is 130, sum of other two will be 50, and these two will be equal. So can I say this angle will be 25 degree, and this angle will also be 25 degree. This angle will also be 25 degree. Now we know that AB is parallel to CD, it is given to us. So this angle X will also be 25 degree, as they are alternate interior angles. Two lines AB is parallel to CD and BC is transversal. BC is the transversal line. So you can say that these two angles will be equal. So our X will be equal to 25 degree. There is second method to solve this question. You can join this AE. You can join this AE. This angle is let's say Y. This angle will also be Y. This is also be Y. Because AC is subtending the both angle in the same segment. These are the angles subtended by the same arc AC in the same segment. Now can we determine the value of Y? Yes, because we know that this AOB, look at this AOBR, arc AB, this angle is 180 degree. We know that angle subtended by semicircle is 90 degree. This angle is 180. This is angle at the center. So the arc AB, look at the arc AB now. Arc AB at the center is angle is 180. The same arc will subtend half of the angle at any point in the circle. So this complete angle AEB will be half of AOB. This is O point. So this will be angle 90 degrees. So if complete angle is 90 degree, so this Y would be how much? This would be 25, because 65 plus 25 will make it 90 degree. If this is 25, this Y will also be equals to 25. This Y will also be equals to 25. And we know that they are alternate interior angles, so this will be also be equals to 25. X and Y will be equal because AB and CD are the parallel lines and BC is the transversal. Next concept is sum of either pair of opposite angles in a cyclic quadrilateral is 180 degree. Now what is the meaning of cyclic quadrilateral? The meaning is that all the four vertices of quadrilateral must pass through the circle. You can see that point A, B, C, D are all the 4 points are on the circle. Same way PQRS is also a cyclic quadrilateral because all the 4 points or all the 4 vertices of quadrilateral are on the circle. So can I say that ABCD is cyclic quadrilateral, and same is true with the PQRS. This is also a cyclic quadrilateral. The concept I want to just discuss is that sum of either pair of opposite angles in a cyclic quadrilateral will be equals to 180 degrees. So can I say that angle A plus C, angle A plus angle C will be equals to 180 degree, as well as angle B plus D will be also be equals to 180 degree. Any type of cyclic quadrilateral, the only condition is that quadrilateral must be cyclic. It means that all the 4 vertices of quadrilateral must lie on the circle. Same way you can say that in this triangle P plus R will be equals to 180 degree and Q plus S will be equals to 180 degree. sum of opposites angle will be equals to 180 degree in a cyclic quadrilateral. Here I am discussing an example. This one of the angle is 100 given to you. This PRQ's angle, its value is 100 degree. You need to find the value of POQ. You should first pause the video, try to solve yourself. What will the value of POQ? Now I can solve this question in two ways. One of the ways that I can make any quadrilateral, cyclic quadrilateral, this point let's say S. Now we know that PQRS, or we can say that PRQS is cyclic quadrilateral, and we just discussed that in a cyclic quadrilateral sum of opposites angle is 180 degrees. So this angle will be 80 degree. 80 degree. Now take the arc PRQ. Now arc PRQ is making an angle 80 degree at any point of the circle. The same arc will make double the angle at the center. So this angle will be 160 degree. This is the way to find. So POQ will be 160 degree. Other way was that you can take that we have given this angle was 100. So what you can do, you can take the arc PSQ. You can take the arc PSQ, this arc PSQ. This PSQ arc is making an angle 100 degree at, you can say that, any point of the circle. The same arc will make 200 degree angle at the center. So total value of angle around any point is 360. So if this angle is 200, so this will be 160 degree. Next is how to find the area of cyclic quadrilateral. This concept is rarely used, very rarely asked in the exam, but still you must know. ABCD is cyclic quadrilateral. The length of the sides of the quadrilateral are given to you A, B, C and D. Small a, small b, small c and small d. So area of cyclic quadrilateral will be S minus A, S minus B, S minus C into S minus D whole square root, where S is equals to A plus B plus C plus D by 2. It's very similar to Heron's formula. S is the semi-perimeter of the quadrilateral. A plus B plus C plus D by 2. You know the value. If you know the value of A, B and C and D, you can find the area of this cyclic quadrilateral. Again, this formula is rarely used, but still you must know if a question can come. So that was all about geometry lesson 9.2 circles basic with example. I will continue with more on circles basic and example in the next lesson. Thank you.